Bonjour and good morning. Welcome to WASA Distance Education and PLAR Math. And this is our second class in week 8. And so after this week, only 1 week of classes left in term 1B. The schedule for term 2A has been posted on Facebook and sent out. So if you want to sign up for classes in term 2A, please talk to your DEC at your learning center or contact someone here at WASA, and we can get you signed up for whichever course that you want to continue to work on. For PLAR students, if you're not finished whatever subject you're working on at the end of this term, then you just continue working on it in term 2A. Okay, you will not be withdrawn at the end of the term, so just keep working on whatever it is you are working on presently. You can participate in classes using radio or Zoom, and the instructions are in your study guide for attending classes. All PLAR Math students are welcome to attend classes, so doesn't matter if you signed up for a PLAR IL or PLAR Radio Zoom, you can still attend the classes. The classes are meant for everyone. To contact me, you can use email, phone, or send a message on Facebook. And the PLAR English classes from last term and the PLAR Math classes from this term are available on YouTube. So you can go to B. Osmond WASA, so my YouTube channel, to watch the PLAR Math and English classes, or you can go to the WASA Distance Education Center site to watch the classes there. And for the WASA Distance Education Center Facebook page, all of the classes are uploaded to that page, so you'll find the PLAR English, Math, History, Geography, and Science, as well as the other WASA classes on the WASA Facebook page. So PLAR students who do not finish whatever you're working on in term 1B, continue working on it in term 2A. Just a reminder that all PLAR students have the option of writing the culminating activity instead of doing the lessons and key questions. So you can choose to do the culminating activity. So even if you have already completed and submitted some of the key questions, you can still decide to switch and try the culminating activity. If you pass the culminating activity, then you will get your missing grade 9 and 10 credits. So if it's English, you'll get your missing grade 9 and 10 English credits. If it's math, you'll get your missing grade 9 and 10 math credits. And then you don't have to do the lessons and key questions, you just move on to the next subject. If you're not successful with the culminating activity, then you will have to do the lessons and key questions, and then once you've finished that, you can write another culminating activity. So you'll get more than one chance to pass the culminating. If you are doing the lessons and key questions, there are two types of questions in the lessons. One is the support questions, the other ones are the key questions. The support questions are the practice questions that you do before you try the key questions. So there are answers to the support question near the end of the lesson. So you can do the support questions, then go to the end, check your answers. If you are doing really well with the support questions, or if you're getting all of the questions right or most of the questions, then you can move on to the key questions. The key questions are the questions that you send out to me for marking. So once you finish the key questions, send them right away. Don't wait until you finish the entire lesson to send out those questions. Okay, to submit your work, there are a few different ways. So the first way, of course, is to give it to your DEC, and your DEC will send it out to us here in Sioux Lookout. If you don't have a DEC, don't have a learning center, or your DEC is away and your learning center is closed, then you can submit your own work. Several ways of doing that. First of all, if you have access to a scanner, you can scan and email your own work to studentwork@nnec.on.ca and CC it to me. Or if you have access to a fax machine, you can fax it to our toll-free fax number. Just remember that if you are submitting your own work, that make sure that you write your name, the subject, and your teacher's name on your work. Okay, if you send it in If you fax it in or you email it or drop it off and there's no name on it, then we don't know whose work it is, and so we can't send it back to you. So make sure that you put your name on your work. Okay, you can also use your smartphone to take photos of your work or scan your work, and then you can email it to that same student work email and CC it to me, or you can send it using Facebook Messenger. The next option is to use our outdoor mailbox. So if you live in Sioux Lookout or the surrounding area and you come to Sioux Lookout often, you can just drop your work into the mailbox that's attached to the side of the building in the parking lot, or you can knock on the front door and give it to whoever answers the door. You can also use Google Docs and send me the link so that I can access your work that way. Make sure though that the link is shareable. And you can use Google Classroom to complete and submit your work as well. So lots of options for completing and submitting your work. At the end of Term B, which is next week, WASA will be having 2 student draws. One draw is for students who earned a credit in the term, and the other one is for some students who submit work. So for every lesson that you submit, your name gets entered into the draw. So for PLAR students, if you complete all 5 lessons, your name will be entered 5 times into the student work draw. If you earn your credit, so for students who earn a credit, your name will go into the credit draw, and your name will also be entered into the student work draw because you also submitted work. So you get 2 entries from getting a credit, and then depending on how much how many lessons you submit, you get more entries for submitting work. So you get lots of opportunities, to win a prize. And so remember, there's only 1 week left in Term 1B, so get your work finished and submitted. Okay, so last day, so on Tuesday, we were working in Lesson 4. Last week we learned how to solve equations, and on Tuesday we learned how to solve multi-step equations, so equations that take more than 1 step to solve. So of course multi means more than 1, so 2 or more, and so solving multi-step equations are more involved than solving 1-step and 2-step equations because they involve more work, more steps. The main goal in solving multi-step equations, just like in 1- and 2-step equations, is to isolate the unknown variable on one side of the equation while keeping the constant or number on the opposite side. However, there is no rule on where to keep the variable. Okay, so the variable can be on the right-hand side or on the left-hand side. It all depends on what you want. The standard or usual way is to have it on the left so that you end up with something like x equals or y equals. But there are cases when it makes more sense to keep it on the right side of the equation. So as I mentioned on Tuesday, look at your variables and see which variable is bigger. So you really should, it's a good idea, I shouldn't say you should, but it's a good idea to keep the variable on the side where the variable is bigger. Because if you're subtracting or adding, you might end up with when you're subtracting or adding, you might end up with a negative variable, and we want to try to avoid that as much as possible. Okay, so let's take a look at this equation. So let me get rid of these circles first. Let's look at this one. So this is a multi-step equation. It's going to take more than 1 step to solve it. So we've got negative 3x minus 32 equals negative 2 times 5 minus 4x. So the first thing we're going to do is look at it and see if there's anything we can simplify. So by looking at it first, we have brackets on this side. So basically what we're going to do here is use the distributive property or expand the operation, or expand the brackets. So we've got negative 2, and we're going to multiply that by 5, which will give us negative 10, and then negative 2 times 4x, which will give us negative 2 times negative 4, times 4, sorry, is negative 8x. Okay, so we have now negative 3x minus 32 equals negative 10 minus 8x. Or we can change that, because if we look at, remember back to the integer rules, minus minus means plus. So now we have negative 3x minus 32 equals negative 10 plus 8x. So now we are going to decide which side is going to be our variable side and which side is going to be our constant side. So on the left I have a negative variable, on the right I have a positive variable. So I'm going to keep my variables on the right hand side because that's where I have a positive one. So what I'm going to do is eliminate this negative 3x from the left hand side. To get rid of the negative 3x, I do the opposite, which is add 3x. And I'm rewriting everything, as you can see here, because I don't want to get mixed up. Sorry, adding 3x. So now I have negative 3x plus 3x, so that's gone. So I'm left with negative 32 on the left. And then I have negative 10, which I'm not doing anything with yet, plus 8x plus 3x. So 8 plus 3 is 11x. So plus 11x. So I've got negative 32 equals negative 10 plus 11x. So now I need to get rid of that constant that's on my variable side. So in order to get rid of a negative 10, I'm going to add 10, and I have to add 10 to both sides of my equation in order to eliminate that variable. So now I have negative 32 plus 10 equals negative 10 plus 10 plus 11x. So negative 32 plus 10 will give me negative 22 equals, that's gone, 11x. So I've done a lot of steps so far. Okay, I used a distributive property up here, and then I started eliminating terms, adding and subtracting to eliminate. I did that twice, once for the variables and once for the constants. And now I'm at negative 22 equals 11x. So I want that x to be by itself, which means I have to get rid of that 11. So 11x means 11 times x, that's multiplication. So in order to get rid of that 11, I have to do the opposite of multiplication, which is division. So now I'm going to divide both sides by what I want to get rid of, which is the 11. So negative 22 divided by 11 is negative 2, and then 11 divided by 11 is 1, so that leaves me with x. So negative 2 equals x. Okay. Now if I did it the other way and I had the constants on the right with the variables on the left, I would still end up with the same answer, but I might end up having to do an extra step just so that my variable isn't negative. Okay, so that's how you solve equations. So the first thing you want to do is look at it to see if there's anything that needs to be done before you start solving. So if there's anything that needs to be simplified or expanded or whatever, and then you look at it and decide which side you want to be the variable side, which side you want to be the constant side, and then you start to eliminate terms. So you got to take your time. You need to write it all down so that you don't get mixed up. Okay, and then the next thing we did was the Cartesian plane. So the parts of the Cartesian plane, first of all, we have the axes, and these are the two lines that intersect to form the Cartesian plane. So you have a horizontal line, so that's a line that goes left to right, which is the x-axis. And then you have a vertical line, which is the line that goes top to bottom or up and down. Excuse me, that's your y-axis. Then we have the origin, and the origin is the point where the lines cross. And the coordinates of that point are 0 and 0. And then we have quadrants, and the quadrants are the sections that that we end up with when the x and the y axes intersect. So we have 4 quadrants. First quadrant upper right, second quadrant upper left, third quadrant lower left, and fourth quadrant lower right. So when we have a Cartesian plane, we can plot points on the coordinate plane or the Cartesian plane. So what we do in order to plot a point is we always start at the origin, at 0 and 0. Okay, that's always our starting point. Then if we have, let's say our coordinates are 3 and -2, the x coordinate is always first. So the x, we have to go along the x-axis, either left or right. Because our first point, our coordinate, is +3, we are going to move our dot over to +3 on the x-axis. Our next coordinate is -2, and -2 is along the y-axis, so we need to move that dot up or down. And because it's -2, we need to go down to -2. So this is our point 3 and -2. Okay? So you can also name points. So if I put this dot randomly, let's see, up here. Okay, so what is that point? So we'll call it A. What is point A? What are the coordinates of point A? So let's see. So we got to do x first and then y. So our x is starting at 0. We went over 1, 2, 3. So it's -3. And for the y, we got to go up or down. So in this case, our point is up. So we're going to go up 1, 2, 3, 4. Till we get to that where that dot is. So the coordinates of point A are -3 and 4. So you can plot points, but you can also name points on a Cartesian plane as well. All right. So we've done solving equations, solving multi-step equations, and ordered pairs. Today we are going to finish up lesson 4 with graphing linear relations and slope. So in your lesson, beginning on page 19 is information on graphing linear relations. On page 20 continues on with some more information on graphing linear relations. Example on page 21, and then on page 22 is support question number 5, pages 22 and 23. Okay, so linear equations. A linear equation is an algebraic equation where each term has an exponent of 1. So, so if it's 3x equals y, or so, okay, I'll show you in a minute. They're basically the numbers are, the numbers are just numbers. So with an exponent of 1, that's 3. The letters are just letters. X exponent 1 is x. So the exponents are 1. So you're not multiplying the base by itself at all. So it has an exponent of 1, and when this equation is graphed, it always results in a straight line. So linear means straight line. This is the reason why it's named a linear equation. Just like any other equation, a linear equation is made up of two expressions set equal to each other. So just like when we're solving equations, we have something will equal something else. How to graph a linear equation. So when we have to graph a linear equation, we start by creating a table of values. A table of values has 2 or 3 columns. Some might have 4. One column lists the x values. One column lists the corresponding y values, while the third lists the ordered pairs. So here we just have we have 2, just x and y. It doesn't list ordered pairs. We don't use those very often. Generally, you will see one like this as x, y, and the ordered pair x and y. Sometimes you will see with a fourth column where the equation is there. So y equals 2x plus 1, and then you solve it in the table. Okay, so for example, graph the following function using a table of values. So there's our equal sign. So we've got y equals 3x plus 1. So what we're actually doing here is we're solving for y. So we are going to substitute values in for x so that we can find out what y is. So first, create a table of values for the equation. Use x to solve for y. You may use different values, but your graph will be the same no matter what values you use. Use the value given for x to look for the values of y in a table provided. Okay, so we've got our table down here, and we're going to figure out what the value of y is first. So our equation is y equals 3x minus 1. So for x, for the first time, we're going to substitute in negative 2. So where am I going to put this? Down here. So y equals 3x minus 1. So for the first time, our value of x is going to be negative 2. Actually, I'll do it here. So y equals 3x minus 1. So y equals 3, and x is going to be negative 2. So times negative 2 minus 1. So y equals 3 times negative 2 is negative 6 minus 1. Y equals negative 6 minus negative 1 is negative 7. So down here in our table, we can work on our table at the same time. When x is negative 2, we said y is negative 7. Okay, so now we do for x if x is negative 1. So the same equation, y equals 3x minus 1, and this time I'm substituting negative 1 for the x. So y equals 3 times negative 1 is negative 3 minus 1, y equals negative 4. So when x is 1, y is negative 4. This time it's if x is 0. So same equation, y equals 3 times 0 minus 1 this time. So y equals 3 times 0 is 0 minus 1, y equals minus 1. So when x is 0, y is minus 1. For x equals 1, y equals 3 times 1 minus 1. Y equals 3 times 1 is 3 minus 1. Y equals 3 take away 1 is 2. So when x is 1, y is 2. For x equals 2, y equals 3 times 2 minus 1. Y equals 3 times 2 is 6 minus 1. Y equals 5. So when x is 2, y is 5. So now we've completed our chart. So let's add on a third column where we do our ordered pairs, x and y, because we have to plot them on a graph. So now I have negative 2, x is negative 2, y is negative 7, x is negative 1, y is negative 4, x is 0, y is negative 1, x is 1, y is 2, and x is 2, y is 5. And I need to put brackets around it because they are ordered pairs. So now I'm going to plot these points on my graph. Whoops, oh, don't want to move my graph. Okay, so the first one is negative 2 and negative 7, so I'm going to start at the origin. X, I got to go over negative 2, and y, I have to go down to negative 7. 2, 3, right. So that's my first point. Next one is negative 1 and negative 4, so start at the origin, negative 1, down negative 4. Next one is 0 and negative 1, so start at my origin. I don't go left or right, I just go down to negative 1. The next one is 1 and 2, so starting at the origin, go over 1, up 2. The next one is 2 and 5, so starting at the origin, go over 2 and up 5. So now, when I draw my line will pass through all 5 points, and it's a straight line. Okay, if one of the dots, let's say this one was over here somewhere, what's that, 0, negative 1, so say somebody put it here, then it's not, I've done something wrong with that when I solved for negative 1, whoops, because that point does not line up with all the other ones. It should be on that line. So if it's not on that line, then I've done something wrong there. Okay, so I need to go back and revisit this equation for when I substituted 0 for x. okay, because your points should all be in a straight line. It can be in a straight line going up or down, across, whatever, but they need to be a straight line. All right, so let's do some practice with, whoops, I don't want to do that. Some practice with solving linear relations. We won't do all these. We probably won't have time, but let's see how many we can do. So number one, we've got y equals 2x minus 3. So I've got my values here for what x is, and so all I have to do is substitute that into my equation. So I'm just going to do my equation up here. Y equals 2, and the first value for x is 2, so 2 times 2 minus 3. So y equals 2 times 2 is 4 minus 3, and 4 minus 3 is 1. So when x is 2, y is 1. So my x and y coordinates are 2 and 1. Okay, so now I'm going to substitute for when x is 1. I'm just going to erase this here because everything else is going to stay the same. So now my x value is 1, so 2 times 1 is 2. And 2 minus 3 is negative 1. So when x is 1, y is negative 1. So my coordinates are 1 and negative 1. Okay, when x is 0, I'm going to put 0 in there. 2 times 0 is 0. 0 minus 3 is negative 3. So when x is 0, y is negative 3. So 0 and negative 3. And then when I substitute my next value, which is negative 1 for x, so I put in negative 1. 2 times negative 1 is negative 2. And negative 2 minus 3 will give me negative 5. So when x is negative 1, y is minus 5. So negative 1 and negative 5 are my coordinates. And then the last one, I am substituting in the value negative 2. So negative 2 goes in there. Negative 2 times a positive 2 is a negative 4. Negative 4 minus 3 is negative 7. So when x is negative 2, y is negative 7. Negative 2, negative 7 are my ordered pair. Okay, let's jump down to number 3. So we got y equals a half x minus 5. So here we have a fraction. So we still do the same thing. We still solve it the same way. So y equals a half, and x is where I'm substituting in minus 5. So here, though, we have no values for x. So all you have to do is put in your own values. Now, because we're multiplying by a half, it's better to use even numbers. So numbers like, let's say, 4, 2, 0, negative 2, negative 4. I'll show you why in a few minutes. So let's do this one first. So y equals a half times, first value for x is 4, a half times 4. So a half times, oops, wrong one. Let's get rid of that. Okay, so a half times 4. So what I have to do is multiply 4 times 1, which will give me 4 over 2 minus 5. Now 4 over 2, 4 divided by 2 is 2 minus 5. 2 minus 5 is negative 3. So when x is 4, y is negative 3. So my coordinates are 4 and negative 3. Okay, so now I'm going to do the same thing. And I'm going to just erase that, keep the parts of the equation the same that I need. And now this time I'm going to use positive 2. So positive 2, so a half of 2. And you can think of it, if you're multiplying by half, you just take a half of the number. So half of 2 is 1. So 1 minus 5, so I can leave out this step here now. 1 minus 5 is negative 4. So when x is positive 2, y is negative 4. So 2 and negative 4. Okay, so then the next one. The next one is 0. So a half of 0 is 0. So 0 take away 5 is negative 5. So when when x is 0, y is negative 5. So 0 and negative 5. And the next one, so the next number that I need to use here is negative 2. A half of negative 2 is negative 1. Negative 1 minus 5 is negative 6. So when x is negative 2, y is negative 6. So negative 2 and negative 6. And then my next one is negative 4. So I substitute negative 4. A half of negative 4 is negative 2. Negative 2 plus negative 5 is negative 7. So then when x is negative 4, y is negative 7. So my coordinates are negative 4 and negative 7. Okay, so if I am doing, like, say, odd numbers, so for example, if I use 3 in there, half of 3 is 1.5 or 1.5. So then I'm dealing with either fractions or I'm dealing with mixed numbers. So 1.5 minus 5. So it gets trickier if we're dealing with decimals or we're dealing with fractions. So 1.5 take away 5 is negative 3.5. So you see you're dealing with fractions or decimals, and that makes it harder to graph. So if you're dealing with your fraction is a half, then you want to use even numbers for your x values. If your fraction is 1/3, then that changes things up. Then you might want to use, you're better off using odd numbers. So, and sometimes you won't have the you won't have the option. You might have to deal with whatever you're given. Okay, so here's a couple of examples again of using if you're given the x value and you're solving for the equation. If you're not given the x value, you just plug in your own numbers. It's better to keep your numbers small as you can, so then that you don't end up with a huge graph. So now, if we are going to graph this, so number 1, y equals 2x minus 3, we'll use 1, 2, 3, 4, 5, the red dots. So our first point is going to be 2 and 1. So I'm going to start at my origin, go over positive 2, and go up 1. Okay, my second point is going to be at 1, positive 1 and negative 1. So back to the origin, over to positive 1, down to negative 1. The next one is going to be 0 and 3. So start at my origin, 0, I stay there, I don't go left or right, but I go down to 3. The next one is negative 1 and negative 5. So start at the origin. Now I have to go to the left of the origin, negative 1, and down negative 5. And the last one is negative 2 and 7. So start at the origin, go over negative 2, and down to negative 7. So there's my line. So now if I'm going to draw a line, and I need a line that has arrows on both sides, arrowheads on both sides, I should say. There we go. Okay, so now I've got my line, and I'm going to make my line red because I want it to match up. So I'm going to draw my line. Oh, it's not red, it's black. Oh well. And I have to extend my line. Oops, I don't want a different line. I'm going to extend my line the length of the graph. Okay, so it's kind of off a little bit, but that's just because of where I placed my dots. There we go. That's better. Okay, so there's my first line. Now my second line, for equation 3, y equals a half x minus 5. So let's use the green dots. So 4 and negative 3. So start at the origin, go over 4, down negative 3. The next one is 2 and negative 4. So start at the origin, over 2, down negative 4. The next one is 0 and negative 5. So 0, down negative 5. The next one is -2 and -6. So -2 down to -6. And the last one is -4 and so over -4 and down -7. Okay, and so for this one, draw my line again. 2 ends, and let's make it 2 ends, and let's see if I can make it actually green. Okay, so here is my line. I'm going to start, draw it, make sure it's the length, full length of the graph, and I have arrow heads on both ends, arrows on both ends, and so there are my graphs for those two. So those are my straight lines, and you can see that all the dots fall on a straight line, which is what should be happening. Okay, so that brings us to, let's go back to here, key question 22, and you have to solve the equation. Make sure you show me your work. Don't forget, when you're putting in your values for y, make sure that you put in your x value and your y value, whatever it is, here inside brackets with a comma separating them. And then when you draw your graph, label the x-axis and the y-axis. So you have to draw your x-axis and y-axis, and then extend the line the full space of the graph and place arrows on both ends of the line. Okay, so you've got A, B, C, and D. So 4 of them to do. The last one has a fraction in it, so take your time with that one. Okay, and that brings us to now something else that is related. Slope. So the slope of a line. So on page 24 of your lesson, you've got some information about slope. On page 25, 26, and then on page 27 is support question number 6. Make sure you do the support questions before. Oh, and then equation for the slope of a line as well on page 28, and then support question number 7. So 2 support questions there dealing with slope. Take your time when you're doing them. Okay, so what is slope? In math, slope is used to describe the steepness and direction of lines. So same thing in life. So if you say, how steep is that hill? So when you're looking at it, you're looking at how steep it is, how high it is, and if it's up or down. Using 2 of the points on the line, so on a graph, you can find the slope of a line by finding the rise and the run. The vertical change between 2 points is called the rise, so vertical, up and down, and the horizontal change is called the run, so left to right. Okay, so slope equals rise over run. So if we look at this diagram, we've got our 2 points here. There's point 1, and there's point 2. So the change between point 1 and point 2 is up and then across. So how far up? 1, 2. So rise is 2, and then the run is how far across? 1, 2, 3, 4 units. So our slope is 2 over 4. So that's how you find the slope of a line, basically. So a line has a positive slope if it starts at the left and moves up to the right. So this is a positive slope. If it starts at the left, and moves down to the right, it has a negative slope. Okay, so a line going up to the right is positive, down to the left is negative. Okay, so let's find the slope of each line. So when we have a graph, it's easy. Basically, all we have to do is count. Okay, so our first point is over here at 0 and -5. Sorry, -5 and 0. I'm doing this backwards. So -5 and 0. And our second point is over here at 5 and 4. Okay, so to find the slope between the first point and our second point, we go up to the height of the second point. So that's 1, 2, 3, 4 units. So our slope is 4 over, and how far across do we need to go? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 4 tenths, or 2/5 if we reduce the fraction. So the slope of that line is 2/5. Okay, number 2, and it's positive because it's going up to the right. So for number 2, here's our first point over here, and here's our second point over here. So the distance from the first point to the second point, we need to go down 1, 2. And if we're going down, that's negative. And then we go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So negative 2/10 or negative 1/5 is the slope. Number 3, to find the slope. So here's our first point up here, and here's our second point down there. So we need to go from our first point over to our second point. 1, 2, 3, 4. And that's our run. So that's the number on the bottom. And our slope is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our rise, I should say, is negative 10 because we went down. So it's negative 10 over 4 or negative 5 over 2 or negative 2.5. Okay, so you can change it. You can leave it like this, or you can reduce it or change it. Okay, our next one, first point, second point. And you notice we're always going from left to right. We don't go backwards. Okay, so our rise is up 1, and our run is the distance, which is 10, so 1/10. And this time it's positive because we're sloping up to the right. So negative slope, you're going down to the left, positive up to the right, or sorry, down to the right. Okay, so finding the slope from 2 points on the line, so without a graph. So if you don't have a graph, you can still find the slope of a line using the coordinates. So every point on a graph has coordinates, and there are always x and y coordinates. So our first point is x1, y1 because it's the first point. The second point is x2, y2 because it's the second point. So to find a slope without a graph, you can just use the coordinates. But you have to keep track of which is which. So for point 1, our coordinates are 0 and 2. So 0 is x, 2 is y. For point 2, our coordinates are negative 2 and 6. Okay, x is negative 2, y is 6. But we're calling them x2 and y2 because they're the second point. Same thing with the first point, we're calling them x1 and y1 because they're the first point. So the formula is slope, m stands for slope, equals y2 minus y1. So our y points are subtracted, and then are over our x points, which are also subtracted. So all we have to do is substitute in. y2 we said is 6. So 6 minus y1 we said is 2. So 6 minus 2 over x2 is negative 2. Take away x1, which is 0. So our y2 minus y1, 6, take away 2. x2 minus x1, negative 2, take away 0. So then we just subtract. 6 take away 2 is 4. Negative 2 take away 0 is negative 2. So we've got positive 4 over negative 2. And we can change that. 4 divided by negative 2 is negative 2. So the slope of the line M is negative 2. Okay, so some things to know. The slope of a horizontal line, so if you have a line that just goes straight across, the slope is 0. So if you do that, work it out, you end up with 0 over 5, which is 0. The slope of a vertical line, so a line that goes straight up and down, is undefined. Okay, because we end up with 2 over 0, and 2 divided by 0 is undefined. There is no answer for 2 over 0, 2 divided by 0, so it's called undefined. Okay, so to find the slope of a line, 2 ways of doing it. You either start at the left and count till you get to the right point. So 1, 2, 3, 4, 5, 6, 7, 8 units. So how far up or down? In this case it's up, it's 8. How far left to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 8/10. So the slope is 8/10 or 4/5. Okay, that's one way of doing it, finding it on the graph. If you don't have a graph, and you have your coordinates, then you can use the formula. Okay, so you just have to substitute in, being very careful that you don't get mixed up. So x1, y1, x2, y2. So our formula is y2, which is 2, take away y1, which is -2, so 2 take away -2, over x2, which is 2, take away x1, which is -3. So then 2 take away 2, which is 2 plus 2 is 4. 2 take away -3, which is 2 plus 3, which is 5. So 4/5. So you can see we got the same slope. 4/5, 4/5. Okay, so if your line, like in this first example, goes up, left to right, it's a positive slope. The second example, if it goes down, left to right, it's a negative slope. Okay, some practice. Find the slope of the font from the pairs of points. So use your formula. y2 minus y1 over x2 minus x1. Okay, so I'm going to label them x1, y1, x2, y2. So my y2 is 5. So 5, take away my y1 is -5 over my x2 is 0, take away my x1 is -4. Okay, so that gives me 5 plus 5, which is 10, over 0 plus 4, which is 4. So 10/4, which I'm going to change to 2 and 2/4, which is 2.5. So my slope is 2.5. Okay, number 2, we've got x1, y1, x2, y2. So our formula is y2, which is -3. Take away y1, which is 0, over x2, which is 0. Take away x1, which is -1. So now I've got -3 take away -0, which is -3, over 0 plus 1, which is 1. So -3 over 1, which is -3. So my slope is -3. Okay, let's do number 3. So x1, y1, x2, y2. So y2 is -4. Take away y1, which is -2. Over x2, which is 3, take away x1, which is -5. So I got a -4 plus 2, which will give me -2, over 3 plus 5, which is 8. So -2/8 or -1/4. So my slope is -1/4. And let's do number 6. So x1, y1, x2, y2. So 3 take away 0 over 5 take away -5. 3 take away 0 is 3. 5 plus 5 is 10. So my slope is 3/10. Okay, so that's how you find the slope using an equation. If you don't have a graph, you don't have to draw one. You just use the equation. So key question 23, find the slope of the following line. So on part A, for A and B, you have graphs. So basically all you got to do is count from first point, 3 and -4, to the second point, 4 and 0. How many spaces up, rise, over how many spaces across, run. So you start on the left, and you go up or down, and go over to the right. B is going to be a negative slope because the line is going down to the right. And then the last question, number 2, find the slope between the following pairs of points using the formula. So don't forget to name your coordinates, x1, y1, x2, y2, and plug them into the formula accordingly. Be very careful, take your time so that you don't get mixed up. Okay, and that's it for our class today, and that's it for lesson 4. So next week we will be going through lesson 5. So make sure you get all of those key questions for lesson 4 finished and submitted for marking.